Hello, let's get started again. So now we're going to hear about some real life case studies where some of our member companies have done RNG projects, and we'll hear about their experiences and lessons learned. I'm going to introduce the speakers all at once and then bring them up as we get to their turn. So Deanna Haynes has worked for the Southern California Gas Company and Sempra in combination since 1988 and has held various leadership positions, primarily in the engineering and environmental areas. As an aside, she's also been very involved in the AGA environmental committees, and I thank her for that. Currently, Deanna leads the utility's energy and environmental policy area to support sensible policies and regulations that are consistent with the primary directive of the utility to deliver safe, reliable, and affordable energy. Before Deanna's current position, she was the director of gas engineering, so she has experience on that side of the house as well, overseeing the engineering standards, training, and research programs related to the design, operation, and construction of the gas infrastructure, which included managing for climate change impacts in the system. Prior to leading the engineering department, she was director of environmental services, responsible for permitting major projects and developing and implementing policies and programs to drive environmental stewardship and support operations with environmental compliance requirements. Now, I'm also going to introduce Luke Morrow, president of Morrow Renewables, and he is going to be talking about a landfill project that's brand new, that's in conjunction with CenterPoint. Luke Morrow is president of Morrow Renewables, a company he and his brother Paul co-own. Morrow Renewables collects, treats, markets, and sells renewable biogas from landfills, as well as manufactures high BTU facilities for other developers. Morrow Renewables has built and operated 10 high BTU projects across the U.S., and they currently operate 8 of those projects. Morrow is the only company in the U.S. that designs, manufactures, finances, installs, owns, and operates high BTU projects. Morrow Renewables is also a founding member of the RNG Coalition, and Luke is on the board of directors. Luke has 17 years experience, over 17 years experience in these high BTU project development development and operation. And he shares authorship of 2 landfill gas treatment patents with his brother Paul and his father David. Didn't know that. Luke has testified before Congress on behalf of the RNG Coalition about current market dynamics and the Renewable Fuel Standard Program and its future beyond 2022. He has a BS in Mechanical Engineering, MBA from Texas Tech, and a master's in theology from Fuller Theological Seminary. And then Rob Bennett, very active in our environmental committees and chair, and Brad Erikstad of Atmos Energy. Rob is manager of the environmental services for Mid-Tex, Texas, and Atmos Pipeline divisions of Atmos Energy Corporation. His role includes all permitting, compliance, reporting responsibilities for the company, as well as work with other divisions of Atmos in environmental compliance. Prior to beginning work with Atmos in 2004, Rob Bennett worked for Encore Electric and TXU, where he oversaw environmental compliance and reporting for both the gas and electric production and transmission assets. In addition, he started his career at Texas Electric Services in the water rights and water resources side. He's a graduate of Texas Christian University with a bachelor's in biology and obtained a master's in environmental science from University of Oklahoma. And I would like to start off with Deanna Haynes from SoCal Gas. Please welcome Deanna.
All right, here we go, clicker. Okay, so I'm going to first talk about who we are, give you some context, talk about RNG basics, which we've kind of covered a little bit today already, the case for RNG and describe some of our projects. So who we are. We're the biggest, baddest, most bionic utility in the nation. Okay, so we serve almost 6 million customers. We've been in business over 135 years. We're old. And we have both San Diego Gas and Electric and SoCal Gas. We're basically the bottom half of the state. The top half of the state is typically PG&E, our friend in the north. Okay, so let me give you some context here. So, everybody knows California is leading the nation in terms of our climate goals. In September, Governor Brown just signed SB 100, which bolstered the renewable portfolio standard to go from 50% renewable electricity by 2030 to 60% by 2030. We also have what's called SB 1383, which is a focus on the short-lived climate pollutants, which methane, of course, is one of those short-lived climate pollutants, along with black carbon, things like that, the fluorocarbons, the refrigerants. The goal is to reduce methane emissions by 40% from 2013 levels. So that's the main policy driver there. And then the governor signed an executive order recently that says, hey, we're just going to transform the whole economy. By 2045, we have to beat the Paris, in 2050, we got to beat it by 5 years here. And we're just going to transform the economy and go carbon neutral by 2045. So that's what's happening in California right now. So, okay, how are we going to get there? Well, we need things that are scalable and we need things that are affordable to solve these issues. The wind, the solar, the hydro, albeit way more sexy than gas, is not going to solve it. We need to have some renewable natural gas, and somehow we're going to have to make it sexy, And of course, like electricity, you can have renewable natural gas. This is our fun little graphic here. Dinosaurs, fossil, geologic, La Brea tar pits. That's La Brea tar pits right there. But we need to look at the biogenic sources, the above ground sources, and that's where the opportunity really lies. Why is this so important? Because most of the methane in the atmosphere right now is coming from those biogenic sources. And our waste, right? Our waste. It's showing up in our inventories. It's showing up in ice core samples in the Arctic. That the methane in the atmosphere is predominantly biogenic. So we need to go after that. We need to go after our waste. Renewable natural gas can do that. This is critical to meeting our goals. The greenhouse gas reduction goals, 35% of the goals is to address the short-lived climate pollutants, which includes mostly methane. 62% of that is methane, as well as black carbon and fluorocarbons. So RNG basics. Let's take a closer look. This is pretty simple, right? We're going to capture methane from the dairies, from the landfills, and we're going to move it into an anaerobic digester that will process it and get it so that it can meet pipeline quality specs and get it into our pipeline. So that's what we're trying to do. We talked a little bit about this already, these terms that are flowing around. What is renewable gas? We say renewable gas is the methane produced from renewable sources like digested organic waste and gasified biomass. A lot of the inventories of what's available for renewable gas does not include the biomass, the forests. There's 130 million dead trees in California because of the drought, and none of that is being included in the potential for biogas or RNG in California. But there's some significant opportunity there. Renewable gas, just calling it renewable gas. Why do we want to do that? Because we do anticipate hydrogen. The hydrogen highway in California is real. We're trying to put in 200 hydrogen stations. We see an opportunity with power to gas. We talked about that earlier. Power to gas is a way to convert excess renewable electricity that's being wasted today. In California, we are wasting and curtailing excess renewable electricity that's being generated during the day when there's no demand, and we want to convert that excess renewable electricity into a gaseous form, hydrogen, namely, or convert it back into methane and make renewable natural gas and put it back into our system. Biogas is a biofuel that is naturally produced from the decomposition of organic waste during anaerobic digestion until biogas is processed to state pipeline standards. It's considered renewable gas. Biomethane is biogas that has been cleaned to the state standards and converted to biomethane or renewable gas. So those are our definitions floating around, and we've heard some other concepts around that, but that's how we define it. So the case for RNG. We looked at renewable gas and how powerful of a tool this is for our greenhouse gas reduction toolbox, and it's big. We had Navigant Consulting who did an analysis that looked at it and said, just 5% of renewable gas in our systems is equivalent to electrifying 30% of the buildings in California and getting those greenhouse gas reductions. That's huge. If we convert 16% of the gas in our system to renewable natural gas, that's equivalent to 100% of electrifying all the buildings in the state of California. So this is a big deal. We could get a lot of reductions, and as we learned this morning, it can be carbon negative. If you use food and green waste and dairy waste in the transportation sector, that's carbon negative. We can literally start reversing the process. So this is a huge opportunity and tool for us to go after the greenhouse gases. So increasing renewable energy in any form is going to cost money, and we need to invest in that. We all know that we need to invest in it. It's a worthwhile investment. So the debate is, how do we get there? How do we do it in a more practical way? So in that same study, they looked at it and they said it's about 3 times more cost effective to use renewable natural gas than to electrify everything. So that is a real key component. If you are able to use both in-state and out-of-state resources of renewable natural gas, it's 3 times more cost effective to get those same greenhouse gas reductions than if you electrify it. And face it, it's more practical. I mean, if you're thinking about 10 million gas meters in the state of California, and let's say you want to convert 30% of those to all electric households, how practical really is that in the next 10 to 12 years? That's hundreds of thousands of conversions a year. And as a consumer, and if you think about it, 90% of our households in California, in our service territory, have mixed fuel homes today. So how many of them are going to go, yeah, go ahead and disrupt my household and upgrade my panel, and I'll go ahead and pay that $7,200 extra to get my panel upgraded? It's just not practical. People prefer natural gas. They prefer it for cooking. It's not a practical thing. It's pie in the sky, and we need practical solutions. There may be some people that are like, hey, I want to do this, and they could do that today. You could go electric today, but there's a reason why they're not. There's a reason why there's 90 out of 100 households that are not, that are mixed fuel. And a lot of people aren't talking about the resiliency issue. That people need a hedge. Most of these climate change events that are occurring today, they're above ground, weather-related events. What infrastructure is above ground? It's the electric infrastructure. What infrastructure is susceptible to these wind events, to this heavy storms, to the hurricanes? How much do you hear about people having natural gas outages in Hurricane Irma and Hurricane Michael? You don't hear about that. You hear about power outages. You hear about extended power outages. So, we need a hedge for people. People don't like to be a captive audience to one energy source. I don't like that. I don't like all my eggs in one basket for my my stock portfolio. Why would I have that for my energy portfolio? So this is we need to think more realistically and practically about how we could do this in renewable natural gas, and that really does give us a practical way to make it not disruptive. The customer doesn't even have to know about it, and if they're really interested, they can voluntarily, start procuring renewable natural gas for their home. Okay, now the big question is there enough renewable natural gas? That's been a big thing. There's not enough of it. Of course there's enough. We make a lot of waste. We have a lot of waste in this country. There's enough renewable natural gas. We have different studies that have put it at anywhere from in-state 90 BCF all the way up to 300 BCF. These are different studies, California Energy Commission, California Air Resources Board, UC Davis. So we've got this huge range in state. Out of state and across the nation, it looks like around 1 trillion cubic feet. The state of California consumes, in the future, it will consume about 1.7 trillion cubic feet of gas. If we're able to displace 16% of that with renewable, that's about 272 BCF. Yeah, we've got enough. We got enough. We make enough waste. We could do this. But is it feasible? You know, we've been involved in this for a while. We demonstrated wastewater treatment back in the 2012 timeline in Escondido. We had a wastewater treatment plant. We demonstrated the technology. The technology is available. The cleanup is available. This is, like somebody said before, this technology has been around for a while. And in fact, SoCal Gas is one of the first to accept, landfill gas into its system years ago from Palos Verdes. Point Loma. This has been in play for about 2012, 6 years now. We've been monitoring Point Loma. They're meeting our higher BTU value. The 990 is our minimum BTU value, which we have been able to get a deviation from. So earlier we talked about how some of the RNG is a little lower BTU. We've looked at that. The California Council on Science and Technology looked at it for our biomethane proceeding, and we do think we could take in a 974 BTU into our system without having any repercussions. It's very interchangeable. But Point Loma has been meeting that spec for 6 years. They've been meeting the siloxane specs. They have used that energy, that RNG, to fuel cells at UC San Diego and at the Baywater Reclamation Plant. So they're putting that through fuel cells. It was a heavily subsidized, plant at the time, but it's working great. It's doing well. This is our newest one. This is a really big one. We just put them onto our system. About 1.5 mile extension to get into our system from this facility. It's a big plant, and it's pretty much self-financed. They haven't had much help, and they're taking advantage of the low carbon fuel standard credits. They're taking advantage of the RINs, but they've pretty much been able to do it before that. They've put in anaerobic digesters, and they're diverting organic waste. So CNR&R is turning greenhouse gas laden organic waste into carbon neutral renewable natural gas. They're using the new near zero trucks for all their waste hauling, which is a major reduction in greenhouse gases from diesel, and and from NOx. The NOx emissions are just dramatically reduced. So they've got about 400 waste trucks that they're using RNG on. Every waste truck use of RNG is equivalent to about 325 gasoline equivalent cars off the road. So, and they're about 130,000. They're taking off about 130,000 cars off the road equivalent. So major reductions from RNG. So, we are developing, more of the market. There's about $110 million right now from the California Department of Food and Agriculture to support dairy gas project. Dairy gas is a huge carbon negative, as Brian and others have talked about. I mean, negative 200 and something is the carbon intensity of that. That's huge, and we're helping get that biogas into our system. And ultimately, we have to think globally, right? We in California only represent 1% of the global greenhouse gas emissions. So why are we doing this? We're doing this because we need to solve the other 99%. And we need to do it in a way that's practical, that's scalable, that's affordable. For example, California's greenhouse gases, about 9% of it comes from its agriculture. Well, on a world scale, that's about a quarter of the greenhouse gases come from agriculture, so about 24%. So what we're doing here is something that we could translate easily to the rest of the world and help reduce their greenhouse gases and make a real dent into this problem. So we need to think bigger, and we need to be able to innovate so that we can solve it at a global level. What's standing in our way? There's a lot of confusion about the supply. Some people and some organizations think there's not enough RNG, and it's like, believe me, you put enough incentives, they will build it, and people will come. It's like Vegas, right? Short-term thinking, people don't realize that, we need to invest in the research. We need to invest in power to gas. We need to invest in carbon capture and utilization. Natural gas is going to remain very inexpensive for a very long time, the conventional sources of natural gas. We are likely going to be able to capture that carbon out of that natural gas in the future and utilize it to make carbon fiber. I anticipate, I'm a chemical engineer, so I get into this. I anticipate that carbon fiber is going to be competitive with fiberglass, and that, we're going to probably start using more carbon fiber as it gets cheaper. Right now, it's much more expensive, and it's used only in certain occasions. And so we are going to be able to capture carbon and make carbon fiber. We're going to be able to make graphene. I've seen at one of my old school, USC, go Trojans, that they are able to take carbon out of methane and make graphene, which is all the touchscreen phones that you have and all the interactive windows in your computers and stuff like that. That's all carbon-based technology. It's graphene. Polyethylene pipe, our gas pipe, we can make from the carbon that we capture and utilize. We can make polyethylene pipe. So the things that we could do and make are really great, and that's where we need technology investment. We need to get people to recognize that we could do other things, and there's other synergies with other things, and create jobs, and not think of this as us versus them, villains versus heroes type of thing. Misunderstanding our infrastructure. There's some that think, oh, natural gas is going to go away, and so your infrastructure is going to go away. It's 100,000 miles of pipe. It's hooked up to 6 million homes. I don't think it's going to go away. And it's a good asset. We could leverage this asset to help us meet the goals. So the people are sometimes very short-sighted, and they don't recognize the value of the infrastructure itself and how it can actually help integrate the renewables with power to gas and things like that. And then just this lack of perspective, they focus on this one thing, it's combustion, things like that, and they don't realize that you can have carbon negative. You have carbon negative things happening by capturing dairies and things like that. So we need an integrated approach. We need all the options on the table. We cannot, let's pick a winner today. This is very complex stuff. We need all the options on the table if we're going to be successful in this, to achieve our goals, preserve the choice for our customers while minimizing that disruption. So we need the fuel cells, we need hydrogen, we need it all. So to reach our climate goals, we need renewable natural gas. So we need to have the agencies, the regulators to support the initiatives for capturing methane from the waste streams, to set procurement standards. Brian talked about SB 1440 that just passed in the state of California, which is to basically have the California Public Utilities Commission consider a procurement or renewable gas standard for the IOUs there. We need to develop the market for renewable gas, and one way to do that is to create the mandate, just like the electricity side, right? They got their RPS. We need a similar thing like for that to help the developers know that there's certainty in the market and that they should be investing in the market. So I do have some appendices, some tools that you could go through when we send it out. I have these handouts out there at the registration desk that we provide to folks. This is something I thought was interesting if you want to know what the value of wastewater treatment biogas is. If you add up the commodity price of natural gas plus the low carbon fuel standard plus the renewable fuel standard, you know, you're getting up into the $44 an MMBTU. We did it for dairy gas, and it looks like about 100 and something. So here's some good stuff for you guys to look at when you have a chance. I don't want to go through it too detailed, but I thought it would be helpful. We had a Power of Waste conference a couple weeks ago, and some of these are from there. So I just want you to know that that's available. So when you do get this and you have time to go through it, there's some really good nuggets in here if you're interested. Okay? Thank you.
And now I'd like to ask Luke Morrow up.
Good morning, everybody. Let me see if I can figure this out. Okay. There we go. So I'm doing a case study today. I'm talking about the North Texas Municipal Water District 121 High BTU project. This project is in the DFW area. It just happens to be about an hour and a half drive from here because it's in North Dallas and you have to go through all the fun traffic. But it's in a city called Melissa, which is just north of McKinney. I've titled this Collaboration, Perseverance, and Success. And now that I say that out loud, I sense that it's kind of sappy, but maybe a little self-serving too. But anyway, it was a great project. We're very excited. It's kind of like, starting off with a win-win-win. It only goes downhill from there. So let me give you a little bit of background on us. She gave some of it in the bio, but Morrow Renewables has built, owned, operated 10 projects across the United States. I think we've done more than anyone else. We are the only company that designs, manufactures, constructs, owns, and operates high BTU landfill projects. We do all of our manufacturing in West Texas, about 300 miles west of here in Midland. So we have the design teams. We're an ASME code shop. We build every part and piece, package, and install and design. We are a founding member of the Renewable Natural Gas Coalition. David spoke earlier, and we are big fans of what's happening there. I'm on the board of directors, and if you're not a member, you should join. It's an absolutely wonderful group that's really pushing this industry forward. The 121 landfill, this is actually a picture up on top of it. It's owned and operated by the North Texas Municipal Water District. It serves primarily, it's a member-owned utility, so it serves the cities of McKinney, Allen, Frisco, Plano, and Richardson primarily for trash. Other trash comes in from other places. They have many member communities that are on the water side, but on the trash side, these are the main ones. And there's a lot of trash. So it is an NSPS facility. It falls under the new source performance standards of the EPA, requiring that the gas be collected and either burned in a flare or put to beneficial use. When we started the project, they were collecting a little over 2,000 tons a day. Right now, they're over 4,000 tons a day and growing. So this is one that kind of caught us off guard in a good way. So they put out a public RFP process. We were awarded the gas development rights to the landfill, and then we took off from there. So on the landfill gas side, they were collecting about 1,800 standard cubic feet a minute going to flare. It had some, typically we find this when we go start a new project, they have air in the system. We've got to go fix issues, holes, problems, and the flow goes down. So it dropped to about 1,600 standard cubic feet a minute when we took over the gas system. So what did we do? We installed over an additional 100 wells, including horizontals, to reduce odors and increase gas flow to the project. And typically when we do this, we'll go and drill a bunch of wells, and our gas flow, we'll think, it's got 70 wells, we drill 70 more, we get 100% more gas. Never the case. We get maybe 20, 15, 20% more gas. This particular one was a great surprise. The gas flow increased to 4,000 SCFM. And when we got there, we would go to City Hall in Melissa to do our permitting. You could smell landfill gas. You smelled it all around. Big problem, lots of complaints, lots of upsets and angers, but the odors have been all but eliminated. We haven't heard of an odor complaint in months. And so, but you can see why, right? You know, when you have 1,600 standard cubic feet being collected and there's 4,000 there, it's going somewhere, right? And it's stinking up neighborhoods, especially as the DFW area really builds out towards that way. Let's see, the pipeline. So Atmos, our buddies here with Atmos, were part of this project. They were about, they have a transmission line about 5 miles away. And this was initially something we were concerned about because it's a pretty good distance. And where you're running through the DFW area, getting right of way is not an easy thing. The right of way was a complete nightmare. We spent about 18 months on it. We ended up just, you know, we ran in a utility easement with a sewer line, missing the sewer line. We only ran through, in the end, 9 landowners, but it was all fields, but we were ducking and dodging future beautification zones and parks and sewers. And so we went all over the place to build this pipeline. And it was a real pain. And timing didn't work out, but Atmos was actually building a line, and are building a line coming right the other way from where we're going. And so that was part of the problem too, is we were both buying right away in the exact same place, and all the landowners were hollering and screaming about everything. But we ended up working everything out, getting our right away, getting it in, having fun with the city of Melissa with their tree permits, which I don't know if anyone's dealt with that, but it's kind of interesting. Now I have 6 feet of pain and suffering. We put in our line, we tied in, and part of the plan was there's not enough demand on the line that we're tied into. So we were Atmos was tying 2 other lines together to drop our gas off. And right when they were getting ready to build that, they realized that some of the right-of-way had lapsed right in the middle of the city of Frisco. So then they hustled and they got that right-of-way secured and got us connected, but we had to wait on that. So we had to flare gas for couple of months in that process, but it all got taken care of. Luckily, they did a great job of jumping on that. Process challenges. So every site is a little bit different. This particular site, that's a picture of our plant right there. I guess I should be pointing to these things. That's our plant. So when we got out to the site, our initial readings were about 450 parts per million hydrogen sulfide. It's jumped up to over 1,000. And I think we're seeing that all across Texas at all our sites. H2S is climbing, not like this, but it's climbing. And so, you know, if you're we typically use like a solid bed, granular substance, sulfotrap, sulfotreat type stuff to remove H2S. It's very expensive when you start getting into these type of numbers. So one of the things we did at this, let me see, is this the pointer? There it is. These 2 tanks here are full of a substance called trizene. It's something we found. It's a liquid scavenger and a little cheaper than the solid stuff. So we are circulating through a tower under vacuum right here, trizene with the gas until it gets spent. So it's a cheaper, more economical way that we found to do this. We're also looking at producing solid sulfur from this particular site, just because even though this is cheaper, it's $100,000 a month worth of trizene. It's a lot of money. Also, the pipeline. Actually, it has a really good specs, 500 parts per million oxygen. The best specs we see are 2,000 ppm typically. We can actually do that, run a field, and get into the pipeline with no trouble at 2,000. 500 is tougher. So at 500, you know, typically right now we have around 300 parts per million coming in from our field. But just because there are times when that's going to go up, you know, lines get hit, you know, you bring in outside air, pumps, over pump. So we put in an oxygen unit, which we have at most of our sites. We run palladium catalysts, so we actually are combusting oxygen across a catalyst with some free hydrogen and whatever methane that is needed to consume that. So we're actually running between 1 and 2 parts per million on this particular site. Our initial plant and compression design was 4,000 SCFM, so typically we'd like to build in about 7 years of future capacity, and we're already there. So, so we're already working on designs and actually installing expansions at this site. We're not even a year in, so that's a great problem to have. Let's see. There we go. The high BTU plant, and you can see there's another picture of it close by the landfill, and you can see the The flare is right there, and so we tied in by the flare, and the main hill is over here. The High BTU plant, we began construction in May of 2017 after we got our right-of-way situated. Of the 10 projects we've done, the permitting was the most difficult at 121. It was no problems with the state air, no problems with EPA, no problems with any air quality, any type of permitting like that. The city of Melissa was just, it's a very small town, but they're trying to grow big, and they really made our life difficult. We put cooling on our drives, our electric drives, and because of that, they considered it habitable because it has air conditioner. So it's hard to make a ADA compliant power distribution center. So we back and forth, and we have you probably noticed we have a fire loop all the way around our plant, and we've never had any fire problems. And it's really, you shut off the gas when you have a fire anyway. But anyway, in our building permit, we didn't end up getting until about 7 months after we were running, and had been working on it for a couple years. So really frustrating, but everything's good now. Power for the project, this is always an issue. We were supposed to get power in May. It showed up at the end of October. I know I've talked to other developers having the same problems right now. We are waiting. We have a very large project in Houston that's about 8,000 standard cubic feet a minute, and we are waiting to get our primary power, and have been waiting, and we're supposed to have it in July. But I'm hoping that it comes soon because we're ready to run without that. So we started the construction in May. We started up in mid-December. By the time we got, once power showed up, we were able to do our checking and start up the project, started selling gas. What the project today is, right now we're selling a little over 3,000 MMBtu per day of renewable natural gas from about 4,000 standard cubic feet a minute. So that's, as I said earlier, we're at plant capacity. All the gas is, all the RNG is going to the vehicle fuel market under the RFS2. We're selling the gas to Shell. It's being transported through Atmos system, and they've been a great partner in that. So what we're doing right now is we're adding blowers to increase the suction on our screw compression on the front end, and we'll increase the capacity to about 7,000 standard cubic feet a minute. We're also making some process changes in the plant. The water district, this is something that's interesting. They're anticipating 5% annual growth per year at the site, so it's going to grow very fast. That whole area is really blowing up and going north. So, we're in the process of trying to be ahead and catch up. In fact, right now we're installing almost 6,000 feet of 24-inch polypipe to increase the size of headers to get more vacuum at the back of the landfill, so we can collect all the gas that's there. So, good problems to have. Project learnings, right away is becoming more and more difficult to get. So if you're a developer, it's never too early to start on your right away. Also, it's never too early to start on power. We always start on power, and we tell them we need power at least 5 months earlier than we really do, and then they're about 7 months late. So that's pretty typical. So never start too early. Great relationships make great projects. Again, a bit of sappiness, but the North Texas Municipal Water District staff are just phenomenal people. They are absolutely wonderful, great to work with, very collaborative. Atmos has been absolutely great to work with, a great partner, and having these close relationships both in the field and then also at a more executive level makes these projects really go. I mean, our local guys and Atmos local guys work together really well. Our local guys at the landfill work really well with the landfill to talk about where's the fill pattern, when can we drill wells, what's going to be affected of ours. So these are things that help get a project off the ground. So collaboration is a huge piece. And as utilities, we really hope that, that you'll see that benefit, that working with us is a great thing. And now this is a soapbox part where I get to give recommendations to utilities because I have a microphone. How about that? Number one, these projects work. There's over 35 years in New York at that project. No issues with corrosion, no issues with complaints from burner tips, no public health issues. You know, once this gas goes through the treatment systems that we have, it's clean. So if you're afraid of it, that's on you in a lot of ways. I mean, I'm certainly all about, you know, the testing protocols that we've looked at. We've run tests as an industry, compared it to natural gas down to, you know, 7 pages of compounds I didn't even know existed. And this stuff is clean. It works. You know, so the next thing I would say is pay attention to the sign of the times. So California has a law that by 2045, there's no more fossil gas power generation. So I don't know if many of you know, but I think some of the crazy legislation starts in California and then it just ends up bleeding its way east until we all end up with some things that are maybe a bit unreasonable. I love natural gas, and I hate, you know, maybe, you know, I grew up in the natural gas industry. We build natural gas treating plants for traditional, for pipelines and for, you know, midstream companies. I love natural gas. I don't think it's a bad thing. I think it's going to be a part of our clean future. But read the sign of the times. Having RNG in your system is a good thing. In fact, I would say it's like a food coloring. A little goes a long way. And I can show you, I can show you exactly what it does to your pipeline. Are you ready for this? There it is. So put a couple drops in and all of a sudden you're green. You know, you're green. And you are a RNG transporter. You are a renewable natural gas advocate. You are green as anyone else. And you know, right or wrong, this is where I think the world's going. People want to see renewable resources. They want to see it in pipelines. Another one, talk to other utilities. You've got Atmos that's been doing this for 10 years. You know, our landfill for a year, they've had 10 years at 20 years, I'm sorry. They've been taking RNG 20 years in Dallas. Yeah, you can ask Brad, I'm sure he'll tell later how many complaints he's had. It'll take him very short time to say the word zero. Same thing that we've seen in Staten Island, same thing. You know, we've been putting RNG in pipelines for 17 years, never a complaint. We've connected to Atmos, several to Gulf South, to Enterprise, to Energy Transfer, to AOGC, to Kansas Gas. We've even had, you know, a little anecdote. We were tying in the Gulf South pipeline in Louisiana. They said, God, we got to study this gas. We don't know what's in it. So we've, you know, probably spent a year talking to them, putting things together. And finally got in, tied in. 2 years later, we're doing a project. We say, what's the closest line? It's Gulf South. And we're like, oh, we're in for it again. We call them and they said, well, tell us where and when that you guys have you're the best supply we have on our entire system. And, you know, really it was just where and when. You know, tell us, we'll get you a tap. And they were quick and they were excited. We have 3 projects tied into them now. And same thing with, you know, we get the same kind of response from Atmos, also Energy Transfer. You know, they will call and say, where's the next one? You know, we love this. It's great for us. It's easy. So I would say this. You saw a map earlier, right, of, you know, here's the states that have some kind of RNG program, right? But you also saw that the state of Texas had no programs, right? And you saw, like, I don't know if Ohio or Pennsylvania have programs either. Well, all of the gas, I mean, Texas has more projects and more gas than any other state. Ohio, Pennsylvania are close behind. And so, but there's trash everywhere. So why is it that these other projects don't get tied in? And I think I can shed a little bit of light on that for you, in that, you know, we looked at a project outside of Chicago and they said, you know, this sounds wonderful. We need you to pay for an 18-month study so we can see what this might do to a burner tip user somewhere, you know, and going into a line with, you know, 200, 300 million standard cubic feet a day. And, you know, eventually we just said, you know what, we're going to go back. We're going to go work with people that'll work with us. You know, we want to work with people that will work with us, but, you know, I think the trouble is, and why I think so much production is happening in Texas, is pipelines really understand interconnects. They understand production. They know that, you know, if someone drills a well, here's what an interconnect looks like. Here's how you do it. It's not scary. But you get, you know, to a lot of utilities in the north, you know, in the Northeast, and they're used to taking gas from other people, not being right in the middle of production. So they don't understand as well that it's not scary, you know. And so that's where I would say, you know, really collaborate with people that are in the production areas, because this is something that is very simple and works really well. And I think a lot of people, when they do their first project, they say, wow, that was easy. You know, it wasn't as scary as we thought, and you know, there wasn't a big outcry from the public. So anyway, those are my musings, and I appreciate your time, and I look forward to any questions you might have. Thank you.
Just to remind folks of who we're seeing next, Rob Bennett and Brad Erikstad from Atmos Energy, talking about another project.
Gee, this is low. Good morning, everybody. I'm gonna introduce us, Atmos Energy, kind of give a little bit of background. We're going to talk about one particular renewable gas project, and I'm going to hand it off to Brad. Brad's our manager of business development for Atmos Pipeline Texas, and has been involved in this particular project since really the kind of mid to late 90s, prior, you know, with a previous owner to us. And so he's been really from the ground floor up of this particular project. So let's see here. Okay. It's not going to be that easy. Okay. Here's our map. Atmos is a mixture of local distribution, natural gas transmission. We've got some underground gas storage. We're up from the northwest corner of Colorado down to the Gulf of Louisiana. We go as far as the western part of Virginia. The largest division is the one that Brad and I are in. That's the Mid-Tex division, and that's the one with the vast majority of the transmission pipeline system. Dadgummit, sorry. Okay, so we've got 3 million natural gas distribution customers. We serve in 8 different states, 1,400 communities, over 70,000 miles of distribution pipe, and 5,600 miles of transmission. And if you read our 10K report, our annual report, you read about Atmos's vision. The vision that Atmos has is to be the safest provider of natural gas. So along those lines, we're committed to spending between $1.3 and $1.9 billion in the next 4 years, replacing infrastructure, making the system safer, more reliable, and new materials, taking out the old stuff, putting in the new. So we're currently receiving pipeline quality gas from 2 projects. Luke talked about one. We want to do more. We've got developers who have presented 6 to 8 potential projects to us. These are all landfill gas that we are considering. We're currently receiving about 7,000 MCF a day from the McComas Bluff landfill, which Brad's going to talk about. 3,100 MCF per day from the Melissa plant. McComas is about 8 miles south of the downtown Dallas area, and Melissa is about 36 miles north of Dallas. And again, as I said, we've been involved in the McComas project since really prior to 1999, but have been taking gas into our system starting in about 2000. And of course, our number one concern is the gas quality from these projects, but there's many others. I think Luke talked about those, one of which is just right-of-way and connecting to our transmission system. It can be the finest gas quality in the world, and if it costs $30 million to put a line to it, it may not be practical for us. And so I'm going to hand this to Brad. This is kind of hard to see. It's a Dallas map. That's the 635 loop that goes around it. Downtown Dallas is in the middle, and there's the McComas Bluff landfill that's down kind of in the southeast corner of that loop. So, Brad?
Thank you, Rob. I'm Brad Erikstad. I'm manager for Atmos, manager of business development for Atmos Pipeline Texas. And I have a question. How many of you live within a quarter of a mile of a landfill? Do I have any hands? We've got one. You and me. Back in 1994, I know I'm off script already. We found a country property, and my wife and I bought a country property at Murphy, Texas. And as we were driving down to meet the landowner to talk about the price, I said, "Honey, don't look now. I think off to the left is another landfill." And sure enough, it was. It was an open landfill. The North Texas Municipal Water District was still operating that. We ended up buying the property. They shut the landfill down, and now there's nobody across the street from us. Isn't that wonderful? Anyway, we did have to hold our nose for about 5 years. It was a landfill that did not have the kind of processes and treatment that we now see to get rid of odors. So anyway, yes, the landfill there is down there. It's pretty close to 635, or actually 20 down there. It is a monster. It's a monster. It's got a lifetime, another 50 years, I think, maybe longer. History of McComas Bluff. This is McComas Bluff landfill. It's the City of Dallas landfill. And all I can say is just growing pains. I got involved in business development for Atmos, actually with what would have been Lone Star Pipeline, TXU Lone Star Pipeline, TXU Gas, back in '97. And since nobody else wanted to mess with the landfill, guess who got it? The new guy. So I have not heard anybody say trash gas today. But when you talk to the pipeline people, they call it trash gas, and I'm trying to change that. We call it renewable. So anyway, there was growing pains. We began negotiating with a company back in '97, and they built the plant, got it up and running in late '99, early 2000. And as any kind of plant, there's ups and downs, whether it's a typical geologic gas plant, out in West Texas, out of the Barnett Shale. There were just ups and downs before things got lined out. And we also had multiple plant owners and operators during the first 5, 6, 7, 8 years of the life of the landfill, which kept it pretty interesting trying to keep up with who was doing what. In fact, Enron had a piece of this thing for a while, for about 6 months, and then they weren't in existence anymore. McComas is, we believe it's the second largest landfill gas plant in Texas, 13th largest in the United States. As Rob had mentioned, I think we're seeing around 7,000 MMBTUs a day coming out of the tailgate. It's taken a while to get there. I think when we first got cranked up with them, they were running 1, 2, 3, maybe 4. They had plans. They thought they might get as high as 15, 20 million a day. But I think right now, I've talked to the plant manager several times over the last couple of years. He says, "Brad, we're pretty much peaked out on what we can accept. And if we get more gas, they have the plant capacity to handle it. And we do have some extra pipeline capacity to handle the gas as well." More growing pains. The plant, what I would think, plant treating, bringing the gas in and treating it, and the monitoring technologies back in the late '90s, they weren't fully mature. They weren't fully mature, and that was a lot of the growing pains that we had. We'd see some excursions on some of the quality, and they'd have to fight like the dickens to get it back under control. But I think the last point on there is maybe the most important, as Luke had said. Atmos, even though we've had some excursions from time to time, we also have enough gas, other gas, coming into that system on the order of 3, 4, 5 to 1 that we can blend down any of those excursions. So we have never received a single gas quality complaint from downstream customers. I haven't heard of a single complaint. The plant, as it was originally designed, I think it was designed to produce maybe up to 4 or 5 million a day tailgate. They upgraded the plant. They added some capacity several years ago, 6 years ago. Nice new plant. They operate both those plants in parallel. And the receipt measuring station was upgraded at that time as well. as I alluded to earlier, the technology for monitoring gas, it had some to be desired, and I think, as most of you all know, technology in electronics and monitoring has improved vastly in the last 20 years, and so we took care of upgrading at that time. People ask questions when a utility, a gas pipeline utility, looks at a measuring station to receive landfill gas in their system. Yes, there's a bit of a terror, not as much as there used to be, but terror of what if they put that raw landfill gas in my pipeline? What's going to happen? And I've been assured that could never happen. So it can't happen. It just goes through too much equipment. But suffice to say, we still put a lot of equipment on our measuring stations, gas chromatographs, moisture analyzers, oxygen analyzers, H2S analyzers, and it drives the cost up such that a fully loaded with all the overheads and tax gross ups, it runs about $1.3, $1.4 million to put one of those in. We want the measuring station usually where we're actually metering the gas. We'd like to have that as close to our transmission pipeline as possible. And that's why the Morrows at the Melissa landfill, they built a pipeline down to us. And we're willing, as far as the measuring station is concerned, is to allow the developer to build a measuring station to our ATMOS specifications. And so as we look forward into doing things in the future, we will be certainly offering that as an option. But the one thing we always retain as far as the receipt measuring station is we always are the operator of that measuring station. We are responsible for making sure that that gas meets quality specifications. And we will always be the operator. We're the operator at McComas, for the operator at Melissa as well. Important considerations. Number one, will the plant be able to meet gas quality specifications? When we began our initial discussions with the people that were putting in the McComas one, there was a lot of question whether they could really meet those specifications with the technology available. And we were not any kind of experts on that kind of thing, but they were able to meet the then specifications that we had at that point, and even now with the upgrades they've made on their plant, they're doing better than ever. Really important, the second point there, the downstream daily customer burner tip load. That's the customers that are actually burning this gas. We must have enough load downstream that we're not overpressuring the pipeline trying to get all that landfill gas into the pipeline. So we want to have some margin of safety where we can take, if the landfill is producing 7 million MMBTUs a day, we are always burning 10, 15 million MMBTUs. It allows us to blend the gas to provide a little bit more stable product for the customers, and also if for some reason there was some dip in consumption, that we could always take that without having to back off the landfill. ATMOS, on that third point, ATMOS odorizes gas where it comes into the system. Most transmission pipelines actually odorize gas where it goes off the system to the LDC. We're kind of unusual because of the way the company grew up over the last 100, 110 years. And so we actually odorize gas where it comes in, and preferably we'd like to have the odorizer up near the landfill, not where there are residential commercial users. An odorizer is as tight as you can make them. You can't make them perfect. So if you ever have a refill or something like that, you start getting calls. So we try to make sure that the odorizer itself is up near the landfill where the meter may not be. So, and on the last point, because of the sophistication of these measuring stations, with all the different types of monitoring we have to make sure that the local ATMOS operators have the skills to operate that relatively sophisticated equipment correctly. We check for the following items: water, H2S, CO2, N2, O2, BTU. So there'll be monitoring equipped for all those things. ATMOS has I guess, a relatively low BTU spec. It's 950. I think some of the other things I've heard this morning, they may approach 980 or 990. But gas in our system already is usually pretty close to 1,000, 1,010, 1,020. It's not a problem. If you went onto our website, you would pull up our current gas quality specifications. Pretty easy to find. Just go to your favorite search engine, just put Atmos gas quality specifications. This will pop up. Those are the specifications that we ask our landfills to meet, which it's really no different. As Luke mentioned, our current spec is 500 parts per million, or where the oxygen spec is, 0.05% by volume. One of the curious things that's going on right now, make a little diversion, chase the rabbit, is that these LNG facilities that are being put in along the Gulf Coast, these liquefaction facilities, are looking for a lower oxygen spec, like 10 parts per million. And Atmos is considering where we have deliveries into some of these interstate and intrastate markets that go down the Gulf Coast, adjusting those specifications to match what other people are doing. So there it is. That's the specification. That's what the future would look like for RNG with Atmos. And that is all I have. So I'll end it with that. Thank you.
So I'm going to have to, so I have to add a chair. We had too many panelists, and because there were just so many interesting things that we had to share with you. I'm going to have a couple of questions for the panelists, but then you can be thinking about what your questions are. I think that the panelists really did a great job, I think, of talking about how gas quality specs can be met. We also heard about how much they cost now. One of the questions I heard from folks when I was just sitting around in the audience is that some who aren't as familiar with how these deals work, they just want to know who pays for this gas at $30 an MMBTU, and how does that work?
Okay, happy to answer that. So in the RFS program, every year the EPA gets together and they set RVO, required volume obligation. So it basically should match up with exactly what we are producing as an industry. They take that number, how many millions of gallons of ethanol equivalent, and they parse that out to refiners based on the amount of refined fuels that they put out, basically to cover for their emissions. So they're required then to buy those RINs that we create. They're required to buy those, and then that becomes part of their fuel mix.
And then the developer gets that money, but the LDC or the pipeline is transporting the gas and gets some creds, just social creds, basically, right?
I wanted to add something to that. I mean, right now at about $1.87, the RIN market translates to about $22 an MMBTU. Then you add the brown gas piece, which is, sorry, we call it brown gas, the non-renewable part. Geological, or blue gas, yes. Blue gas is nice too. Sounds better than brown. But so that adds about another $3. So that puts us kind of in the mid-20s. And then if you're in the LCFS market, you can add more to that. One of the things that hasn't been addressed, though, is out of that money, that gas has to go into a vehicle. So it has to go through a dispenser. And we have to pay that dispenser to take our gas over other gas. So they share in the RIN, and they also share in the LCFS if we're doing LCFS. So we're having to, we have tolls to pay along the way to get into vehicles. So the pipelines are, we'll sell the gas to a Shell or a BP or someone else in the industry. They'll take the green attributes off of that gas, then resell the gas into the local market. Those attributes are then taken and transferred to a spot that is going into a vehicle fuel dispenser, and that's where the RIN is created. But so we have to pay the value chain along the way. So it doesn't just go straight to us.
Thanks. And let's pause for a moment and see if we have audience questions, because I think we're getting up to our time limit. Yes?
Luke or Jeff, I'm wondering why not self-generate your power? Is that because the gas is worth so much?
Yes.
Yes. Correct.
Yeah, I mean, if we can buy power for, 4 cents and sell gas for 30 an MMBTU,
it's a pretty easy, it's also great because we run all electric compression, everything's electric for us. So when we actually hit the site we're permitting, we're actually cutting the site emissions by 60% over flaring, because we're taking that methane that would be converted to CO2, putting it in a pipeline, and not creating any new emissions. So, when you want to self-generate your own power, then you got to worry about SOx and NOx and everything else in your permitting.
We're considering self-generation only from the waste gas stream. There's actually a pretty significant waste gas stream that comes out. But reciprocating engines are probably the best consumer of a lower BTU fuel. It certainly isn't high BTU. Reciprocating engines like about 45%, less than that. They really don't like very much. So that's a consideration. And then also, again, in most cases, we're on a landfill. So the environmental permitting and complications between a landfill's operating permit and our operating permit, we're a spec to the landfill business. So they aren't really interested in us impugning their air permits unless absolutely necessary.
And one other thing I would add about value chain is for us to get the gas rights to a landfill, we don't just saunter in and say, give us the gas rights. We pay a royalty for the gas. So we pay, there's different contracts, different ways. Some people pay a set amount of money per MMBTU. Some, like most of the deals we do, are a percentage of gross. So the landfills actually, we have one particular site in South Texas that, the landfill brings in maybe $10 million to the entire community, goes to their bottom line. Our plant coming in has added another $1.5 million and taken over their compliance that they would have had to take care of. So we've added a couple $1 million to their bottom line just by being there.
I've got a question for Brad. I just took a note of this. Just to clarify, because you were talking about before 6 years ago, there were some excursions that were experienced with this older monitoring and cleaning technology. But when you upgraded and upsized 6 years ago, have you had any problems since then?
I think it could be good. I think when you look at pipelines,
For the people on the web.
when you look at pipelines, we're a kinder, friendlier pipeline. We recognize that your gas, even from wellheads or landfills, it may not be perfect all the time. And if we see something get up and above a specification, a conversation will begin between the landfill, the plant, and gas control. And they'll say, well, this is the problem. We'll be okay in 30 minutes. And as long as the gas hasn't gone, to the moon on water or nitrogen or something like that, we'll give them an opportunity to get the process under control. There's one particular spec that we don't flex on is H2S. 4 parts per million is an automatic shut in. But the others, water, our spec 7, if they're doing 8 or 9, we'll have a conversation about it. The gas is getting blended with other gases that's hitting the pipe. So
I have a question.
Yeah, okay.
Why is there such variance from one LDC to another? Like I showed.
well, we're a pipeline. Atmos, I represent Atmos Pipeline Texas, and we then deliver that gas to the LDC. If you're delivering gas directly into an LDC, they may look at it a little bit more carefully, because basically there's no blending, there's nothing else. You're getting the straight product. At McComas, I think the McComas gas is probably just half or less of the total stream going to the customer. So in the winter, it probably goes down to 1 in 10. There's huge load going into Dallas, or a huge amount of gas to feed the load going to Dallas. And at that point, the 7,000 from McComas might just be 10, 20% of the total consumed gas in the system.
Yeah, just to add to that, our not every system is built the same. It doesn't have the same demands. It doesn't have the same gas throughout. It's not homogeneous gas throughout. We have about 45 local producers that add gas to the system, and we have about 5 interconnects with interstate transmission pipelines. So the gas quality could vary depending on different regions of our system. And we have to make sure that the end use remains, you know, that any gas that we bring into the system is compatible with the end use in that area, that people don't have problems with the interchangeability of the gas, and that their appliances work correctly, things work correctly. And just a comment on our 990, we have probably the highest BTU spec in the nation. We just got approval to deviate from that. So that, you know, there was a study done by the California Council on Science and Technology, and it said that as long as you're meeting the WOBE, which is the interchangeability criteria, that, and all the other criteria, inerts and things like that, we could deviate from the 990. So developers can now ask for deviations from that 990.
Well, we're up against our time, but I wanted to give a plug for the next panel after lunch, which is going to be on gas quality and a lot of the technical research that's been done. So we can continue that discussion at that point. And shall we go ahead and break for lunch or take one more? What do you think, Rosalie? Are there any other questions out there? Oh, we do have one. Okay, we'll do one.
Yeah,
So what generation is providing that force and power?
okay, so, that is certainly considered when you're, especially when you're going into California market for low carbon fuel standard credit. They do take into account, you know, all of your power and your waste sources. Even they take into account, do you use, the fossil gas for your incineration, or do you use, your treated gas for that? So all that goes into account when you're looking at low carbon fuel standard credits. The RFS is more silent on that because we're actually making a vehicle fuel and not accounting for life cycle of you know, the energy coming in to run equipment.
All right, I'm going to call it a close, but I want to, just on the lunch side, I want to remind you all, you will need your RNG workshop name badges on in order to get into the lunchroom. This is a special lunch just for this workshop, so if you didn't pick it up already, they're sitting out there at the front desk. Thanks.